This is the practice test that you gave them.
Yep. Yep.
So starting off, you're gonna have always like your import NP, import data science, and then you have your random choice variable. All that's saying is it's giving you a list and then it's going up in a factor of two. Um, and it gives you the output, so you already have that given to you. Um, so some of the ways to like think about the first question, you want to think of this as your initialization. Um, and you're just initializing total to zero. So it's like a blank slate, you're starting off with zero. And then every time you try to pull something into zero, or into total rather than zero, um, you're adding one, or you're adding every time you go into this range, you're adding something to total, is what this is saying. And then it's kind of like for eyes, you can really put anything here. Like I could put X here and then change this to X. So every time you call something, you're just bringing it in and then adding it to this variable, which we've defined as total. You don't even have to do print total. You can just write total. Um, So it's just drawing from this, and then it's adding all of those numbers together to get your total, which is net. So we're using this in a more broad sense for the next question, which is it gives you a list and then you initialize your variable for above 10. And for this, we're trying to find values in the data set above 10. And then every time we find one of those, we're adding one to our above 10 variable. So one of the ways I broke this down is if you're like really struggling with all of these like if, elif, and else statements, you can kind of just do them one at a time in a notebook like this one. Um, so I just did the initial function itself and then just whatever output comes out from it. So we'll run this first and we get two. So anytime this value in this list comes out above 10, we're adding a number, and 12 and 15 are the two numbers that are greater than 10. So obviously your above 10 variable is going to come out with two if it goes through each of the numbers in this list. So based on that, if we run this, we get some large values. So it's drawing from this list, and it's going through that, and it's finding that above 10 is bigger than zero, but it's not bigger than len data over two. So what is len data over two? Um, we can actually just run len data and then len data over two, but it's just talking about the length of the list itself, and then we're dividing the length of the list by two. So there's six numbers in this list, and then that divided by two is just three. So it's really just saying if above 10 is above three, then it's mostly large values. So how can we get above 10 to be greater than three? Well, if we just run this enough times, it'll come up with a random number each time. So we'll eventually get that. But if we want to only get mostly large values, we can actually change the data set, or if we take this and put this here, anytime that oh, anytime this data set goes above three, so we add more big numbers into this data set, we can get this to be above three. Um, it can also just happen naturally by running this a couple times, but it's not gonna go below this because we have two numbers that are greater than 10. So we're usually not going to get this unless we remove the 15 and we remove the 12. So if we do that, then we get no large values. And if we just add like 12, 13, 14 or something, then we'll get mostly large values. So you can kind of just play around with the list and see how it affects what you get out of it. You can also break it up and just see, like, if we add it here, then we'll get 3 instead of 2 for a row of 10. So that's another way to do it. So when you don't really like understand the function or you just get overwhelmed by like all of these statements, you can kind of like break it up and try to just see what you get out of it by just breaking it up and doing it one at a time. Um, and it's kind of the same thing for whenever you define a function. So for double values, we want numbers. That's going to be our only input for this function. And from that, we want it to double the value. So same thing, we are initializing result, but instead of initializing it with a 0, we're initializing it with an empty list. And in that empty list, every time this is an arbitrary variable in numbers, which is our input. So anytime we put in a number in numbers, we're going to get that number times 2. So whatever's in our list is going to be times 2. So if we run sample data, which is a filled list, then it's going to give us double of each of those numbers. And that's exactly what we get. So we get 6, 14, 2, 18, which is the double of all of these numbers in this list. And we can even just try making a function right now. So let's say if we wanted to triple everything, do, and then it's going to be the same as this, but slightly different. Instead of, 2, we can put 3 in here, and then run this. Oh yeah, that makes sense. And then if we just use the same data set, we can do triple sample data, and we get 3 times all those numbers. So 3 times 3, 3 times 7, 3 times 1, and 3 times 9. So anytime you have a function, you can kind of just think of it as whatever you define your function name as, and then what you're putting into the function. And then this is all the stuff that's going to make your function work. So you have your initialize statement, and then you have your for in. So your variables of whatever you're putting in. So if you want to put in a list instead of just one number at a time, that's what you use this for. And then anytime any number from that list is going in, you're going to have that be times 3. So hopefully that makes it simpler to think about. And then we can go into hypothesis testing, which is all that table stuff. So once we make our table, this is just adding columns, making one column at a time, building that table up. So once we have this table, we can actually do stuff with the data in this table. So this first part, we're doing an average of all of these columns based on the office visits. So sorting it by office visits, we have either 1 office visit or 0 office visits in our data set. So it's getting selected based off of that, and then we're doing the average of all the other columns based on office visits. So the student number average is just based on whatever student ID number that they are given. So this column's not really useful for us, but our attendance average and our score average actually gives us interesting data. And it shows that as you have more office visits, in this case, one more, you get a higher attendance and score average. So then we can use these two score average columns and find the difference in the means of them because average is just mean. So one here is just noting that it's the second data point, and then 0 is noting the first data point. And this is the average between those two data points. And if you just bring out a calculator and do it, then you'll get the same number. So then we can also do from before we group them by office visits, we can use this table to shuffle the random number of office visits based on this table and just pick a random student and how many office visits they've made. Um, and another thing with hypotheses and null hypothesis and more specificity. Whenever you have a null hypothesis, you always want to say that it's due to a random occurrence or something along the lines of that, just because you not only want to imply that it's not because of your hypothesis, but it's because of random chance and random occurrence, because it can happen to any data set. You want to have it more so in general terms rather than specific terms of your data set. You can have both, but you definitely want to have it's due to random occurrence or random chance. Um, and then we can also take our data table and use the shuffle function to just change whichever student ID and attendance and everything between the students. So I'll just mess up the rows and bring them into a shuffled manner. And I think there's a question on this. Yeah, so it's talking about using the shuffle function and what it does. So the shuffle function is you use your table.num rows to find num, and you're gonna put a table name in and your label in. So these are your two inputs for your shuffle function. This is how your function is gonna work. It's gonna use table.shuffle to shuffle table, and then it's gonna form a new table based off of that, and then it's gonna return that table. So we can test it here. So we have our ADS grade table from up here. So this is our original table, and then we're going to use that, shuffle it with our office visit, and then it'll make a column that is our shuffle column. And then this is, oh wait, yeah, this is our shuffle column. So because we already have a column with office visit, it put simulated. So this is our simulated office visits, which is randomized, and it just picks a number between 1 and 0, or either 1 or 0. And it's just going to give us a random shuffled office visit that supposedly happened. So we can use this to simulate distributions and data in general. So we can run this another time and it'll just shuffle the data again. So based on this table that we just made, we can run our same diff means where our score averages were calculated between how many office visits a student did and what their score was. So our simulated scores seem to show negative correlation. So in this case, you actually got lower score for going to the office hours. Um, which is kind of funny. So then we can plot that data and we can get a 95% confidence interval, which is what this line is. And as well as a p-value. So this, we're just using an array of 1,000 data points, and we're shuffling the table based on office visits and using this NP average and diff mean score and just calculating all of that. And then we're plotting 1,000 of those points and seeing how it affects the distribution of scores and specifically the diff mean between those scores and office visits. So it's a standard bell curve. So you have 0 being the most. So that's what simulation data usually does. You have most of your data is just showing that it's not going to affect anything. And then you have your two extremes as they go down. And then this is your 95% confidence interval on going to office hours is going to make your score average go up. And then we can use a p-value on that, on this bar graph, and use the result we get here, diff means from it, and then our len, which is our total number of data points. And if our result is higher than the mean average, we get a p-value. We can do the p-value of that, and our p-value is really low. So in this case, it actually does help, and that actually supports our